Now, in this final section of today, then we speak about those two types of translocations and soil development processes that involve more of the evapotranspiration and less of the precipitation, rainfall. So in this case, first I'll put here salinization. Which mainly is about salt. And the other one is calcification. Which mainly will be about calcium carbonate, CaCO3, or gypsum. And there are slight differences here between them, where and how they develop, but altogether we definitely need to highlight the role of evapotranspiration. So evapotranspiration. What can cause this evapotranspiration? Firstly, we can say in general it will be about an arid landscape, arid climate. So aridity. But for salinization, so I put this division here, this division line. For salinization, it can be much more like man-made as well. It can be natural, so in general the soil has a poor drainage, so the water is not able to run down into the soil properly. And this will mean that leaching cannot really happen. So leaching was interesting because we said that it can be very often problematic. But actually, leaching has to be in a kind of balance. There needs to be some leaching because things like salt should be able to be dissolved and washed away to some extent. And this poor drainage, or we can say also saline water table, so salty water table can be causing this. And much more, the removal of vegetation, so deforestation, cutting out the normal trees and so on in a land that is arid by climate, that can cause to further desertification. So removal of a forest can mean that the whole soil system will change, become salty on the top, and so further on no vegetation will be able to survive. So I just put here deforestation. And there's one more point. And that final point is going to be irrigation. So whenever there's a kind of soil that is located in an arid landscape. Irrigation itself, agriculture, activizing and kind of intensifying agriculture through irrigation, watering of the crops, can enhance salinization. So these are just some of the possible reasons for this happening. And calcification, again, is mainly about arid landscape, but it can be related to a kind of local soil or parent material that leads to the ability of calcium carbonate and gypsum to accumulate. And perhaps also here we can say that the seasonality of rainfall can be a reason. So seasonal downward movement of materials. Okay, in this case, we're not going to be speaking so much about different kinds of processes. It's much more about one simple event. And in this case, for salinization, we just mentioned that it's the occasional downward movement from like an A horizon of some dissolved salts. I put here dissolved salts. And at the same time, much more stronger can be the accumulation over here. Of the salt, and the salt crust can develop. Right on the surface, we have these little crystals of precipitated salt on the surface. And if we had a saline water table, this one, that means there is saline water on the soil, then capillary movement will be able to attract that water and the salt content to the surface. So this is salts moving downwards only can be occasional or seasonal. It's much more the accumulation of salt or the development of the salt crust on the surface that will develop. We can have here A2, B2, C2 horizons developing, but we don't really need to memorize these because they're so irrelevant. It's really the salt on the top that is relevant for us. Now, for calcification, it will be a little bit different because it's not the surface that directly will be affected. Instead, here it's going to be a couple of meters around the B and the C horizon that will really be affected. So in an A horizon, we will have some kind of organic matter. That's fine as usual. But what happens here is that the seasonally happening downward percolation of the water together with some of these kind of carbonates and gypsum will be able to end up in the B or the sea horizon. So here we have development of a Cossack horizon. Or what can happen is around this area, or maybe a little bit below, of a gypsum ridge, so that would be a gypsic horizon. And this would be somewhere around the BC horizon, so it can be BK or a B and Y, or a CK or CY horizon that develops for a Cossack or gypsic horizon. What this will mean, that here we have calcium carbonate or gypsum in this layer, is that this will be a very hard kind of rock solid material. And that's what we're talking about in Earth Surface Environments module as well, that calcification will affect the surface as well, because this material is going to be protecting the underlying bedrock as well. It cannot really be weathered if this is such a hard material where calcium carbonate accumulated, and really things like yardongs or zeugen, these kinds of rock formation where there is a really a hard rock surface on the top that originally was developed thanks to the soil, so that one will be able to protect the softer underlying material which was not affected by these soil forming processes. So that's the relevance of calcification, not only in terms of like soil forming processes, but also geomorphology, or the development of the surface as well. So these are just some of the points which I wanted to highlight. There are lots of other soil forming processes which would be of relevance in various points of the planet. Different composing soil forming processes or translocation processes would have relevance. These are just some of the points I wanted to highlight. And again, here for salinization, I wanted to say that it's very similar to calcification, but here we can also think about leaching and the lack of leaching that would make this interesting to us, just to combine the different translocation processes, how they can be related or have in kind of importance to each other. So these will be in the exam to some extent. Most of the material that the soil kind of lectures or soil topics lectures were finished with, desertification or the social problems or how soil degradation happens and why it's a problem, will not be included in long answer questions. So you should concentrate on these, because these definitely will appear in long answer questions, one of them or two of them, to compare or to discuss relationships or reasons and how different soil horizons will develop. Here we got A2, B2, C2. Here we got A, BK, BY, CK, or CY. So these are things that we need to know, as well as at least some of the reasons why these happen and the kind of materials that are playing key roles: salt, calcium carbonate, gypsum, and where it happens on the surface or in the A horizon mainly, and the B and C horizons for calcification. So these are just some of the key points that we should know about before we prepare for the exam.